Welcome, Joshua Owens. Can you tell us a little bit about Byzantion and what you guys are trying to achieve?
So Byzantion, we're a multi-chain indexer. And the problem that we really kind of focus on and solve for any of our partners and kind of application developers is when you're building an application, reading data and the data that you need for your business off the blockchain can be fairly difficult. One, you're going to have to build a purpose-built indexer. If you ever, and over the life cycle of your company, you're going to have like a V1, V2, V3, V4 of your smart contracts that you're building your business on top of. And typically those come with different data model, like internal data model changes for those smart contracts, or you want to implement like other third-party smart contracts on the chain. So what we do is we build a universal data layer that keeps track of state and actions and kind of serves you the data that you need to build your application on top of. So we operate as a middle interface layer for application developers.
For those that are listening that don't really understand how blockchains work, they're state machines, right? You know, the data exists that is there today, but all the data that used to be there, like the historical state, is gone, like it's permanently gone. And the only way that you can go and get it is you have to read like the history of all of the blockchain and then parse it and cache it and then index it. So maybe you want to go over a little bit about what that actual process is like.
Yeah, and maybe for like a analog version, we've been using this recently. It seems to kind of help people understand because everybody has a bank account. And typically when you go to check your bank account, you want to see the balance. And of course, like if you're a business, you're going to have your own bookkeeping, but you want to get like the state of like, what is your balance inside that bank account? What would be really annoying, and this is kind of how blockchains work, is if you went to your bank account and it just gave you all the like just your bank statement, so all your receipts over a very long period of time, they don't actually give you that balance. And so there's like just very simple things you want to do is like check my balance today or check my balance from 30 days ago, like what was actually my account. Instead of having to like go through all those transactions to do that, you just want to see your balance. Like that's a good UX. So what we do for blockchain is kind of very similar. The blockchain, what it does is if you run what's called like an API node and an RPC node, different ecosystems have different terminology. But you have this node that gets all valid transactions set to it, and it kind of like spits them off. And so the very first thing that we do when we go to index a chain is first we have to get all transactions that have ever happened inside that chain. And we want to make sure that we have like the canonical versions of chains. As people know, like you can sign a transaction that fails. Depending on the blockchain architecture, sometimes those transactions will fail within the block it was executed in. And then things like near, which are asynchronous, transactions actually confirm across multiple blocks. So if something fails on block 6, you want that whole transaction is no longer valid. So when we go to index a chain, the very first thing we do is we set up an RPC node or an API node. We receive all transactions and then we store them in what we call like just a data lake. So these are all just raw transaction formats. It keeps track of the canonical version of the chain, so we don't have like non-canonical transactions inside that data lake. There's a lot of logic that goes into that. And then we have to like make it ready to be easily queryable. So if you're gonna query something from 2 years ago, you want to make sure that's very fast. So there's a lot of logic. The next thing we do is we convert transactions into what we call like a universal transaction. Right now, we're primarily focused on NFT data. That's where most of our clients are. We could do this for kind of any other model, but we really focus on NFTs. And our first goal when we index a chain is to get to what we call true ownership. So if you just take NFTs as our like example use case here, to get to ownership, you need really 3 things. One, you need mints. So when that NFT is created, you need transfers, and then you need burns. So when NFTs are destroyed. And if you get all 3 of those things, then you get what you can call ownership, where you can actually query a wallet and see what NFTs or what that wallet owns if you have all of those indexed. The next layer on top of that is we kind of take a different approach than most other indexers. If you think of something like the Graph or Zora or Moralis, etc. If you take the Graph, when you try to get into the state layer, so you have ownership and now you want to see the state of any smart contract. What the Graph does is it builds like a one-to-one mapping of contract state to like the way you're querying it. So you're going to query that contract the way that that contract kind of represents data on chain. What we do is we build data models for concepts. So whether that's a marketplace or an inside of a marketplace, what should a listing look like? What should a bid? What should an order book bid? What should, a bid with a timeout? What should kind of all these different types of actions, what should they look like and how should they be represented? So we build vertical, what we call micro indexers for specific use cases. So like an AMM or a marketplace or a staking contract. And then we convert the transactions into a universal format that extracts that data and builds a state model on the back end and also an actions model. So that's kind of our layers. So once you convert those transactions, we shoot them through our micro indexers and we get state on the back end. And then it allows you to do like very complex queries. Doesn't sound complex, but it is kind of the more traditional sense of like, show me every NFT of this type listed across all marketplaces. And then say less than, 500 in the fungible token with the specific attribute. So that's what when we do indexing, that's at the state layer. And then there's a lot of other data that you might want. So like, what is the metadata for that NFT? What are the IPFS images? A lot of quality of life features, as well as, you sign a transaction on December 22nd of 2021. The fungible token value in fiat terms is very different than it is today. So what was the, USD price back then? And if I sell it today, like what's the P&L? So we have our own currency engines as well.
But before you were talking about how you guys are focused on NFT standards right now, but I think like buried in that was that in principle, you guys can target any smart contract and any of the data which would be associated with it, right? Any of the actions that would be associated with it. Is there any specific reason why you guys decided to target NFT standards and not, the myriad data or the myriad smart contracts that are available on the market?
Yeah, I mean, really, it's kind of like a path dependency function. So when we got started, and like even how we came into this problem, kind of realized it's a real pain in the butt. We ran the largest marketplace inside the Stacks ecosystem. So we had about 70% market share there, and we started with NFTs. So we understand that and now we operate across 3 chains, Stacks, Near, and Aptos. So we really understand the NFT ecosystem, to the point where we can move, and we know most of the edge cases as we've written a lot of the NFT standards inside those ecosystems. So when we expand as a company going into new chains, we have a very good view of what NFT data models should look like and what are all the edge cases, so we can move very rapidly into new chains. When it comes to things like DAOs and DeFi products, just our experience isn't as structured there. So we sit down with those clients. We're actually working with 2 DAO clients at the moment, and really understanding kind of all the edge cases and what should those models look like. So that's why we've kind of primarily focused on NFTs. The vast majority of our clients right now are NFT clients. That's where we got started, but we're starting to branch out at the moment.
You talked about a lot of abstraction before, the different layers that you guys are building, which allows, kind of from a functional perspective, people to query data in a way which they don't have to understand the underlying principles of the data. Maybe you want to talk a little bit more about like what the actual advantages of abstraction of NFT data is for developers?
Yeah, great question. So if we took a step back and like, if you're a project builder and let's just take the marketplace as a use case. It's widely known. Most people have like interacted with the marketplace, and maybe you want to build one in the future as well. Typically what has happened, and from our experience, is you'll build a marketplace and you'll build, like, say, your first marketplace smart contract. And typically, let's just say that first contract has listings, and it has, so you can like buy and sell at a very basic level. And you build an indexer that is indexing kind of buys and lists. But let's say in V1.1, so your next version, you want to put an expiration date on that listing. Well, what's going to happen there is your whole, like, the data model that you are using inside that smart contract for listing is going to dramatically change. And you've built kind of your indexer to your first contract. And so now when you try to go, contract 1 and contract 2 and serve them inside the UI, you're dealing with 2 different data models. So you'll have to build 2 indexers, and then you have to do a lot of organization on the application front end to like make these 2 data models work together. And that's just like, that's your own contracts. That's happening. You're not even adding third-party contracts. But you can think of like the life cycle of your company. You're going to make a lot of different changes and a lot of upgrades. And you may want to start implementing kind of smart contracts that third parties are building as well. And they don't have you in mind. They're not catering to your data models. And you get stuck. So eventually what happens is to the overhead cost of making a smart contract data model change becomes too great because you're going to have to completely rebuild your infrastructure. So you can think of these like you're just always adding new data types. And what you really need is you need this universal layer to where the core constraint is no longer the data model because it's causing you to rebuild your whole infrastructure and rebuild your whole front end. So that's where like a lot of the advantages are for people who use us is they know, okay, I'm going to come in here. I'm going to use this data model. I can build my application. And if I want to add a new contract, or if I want to go into a new ecosystem with a very different underlying blockchain architecture, I can do that rapidly. So instead of that taking me months of go to market, a lot of money and a lot of maintenance is, we solve that problem for you. We do all the conversions. And that like the data model that you're building on today is the same data model you can build on 2 years from now without having to do these re-architectures.
I guess that means that for developers that may have the necessity to migrate from one network to another, it makes that migration all that much easier.
Correct. Yeah. So if you're like, let's just say you wanted to go to near to Aptos or, any of them, and we'll be adding a lot of chains. The go-to-market now is like a day. So really what you have to do is you copy, paste your queries that you already had set up for your existing ecosystem into the new ecosystem. Everything's going to look the same. And now you just need to figure out like how to sign new transactions. And that's the overhead lift that's involved rather than building a whole new kind of architecture beneath it.
There's a lot of data that lives on chain, right? And there's also a lot of really important data that for most chains lives elsewhere. For example, marketplaces and all of their internal data. Maybe you can talk a little bit about that.
Yeah, so there's, I think the most prevalent, say, decoupling between important on-chain data that's being stored off-chain. And if we just take the NFT ecosystem and marketplaces, say like listing prices. So you really see this more in ETH than other ecosystems as the transaction fee cost was so high that inside a lot of the smart contract work, we were trying to save the end consumer to not have to pay a ton of gas prices. And so what OpenSea kind of historically has done is they haven't been storing their list. So you can see the listing on chain, but you can't see the list price data. You actually have to hit a third-party API for that. Of course, there's also a lot of off-chain stuff like metadata. Metadata gets updated pretty frequently for NFTs. New NFTs come online and scraping engines there. So we can tackle kind of those two things separately. But first, we start with listing data. So outside of the ETH ecosystem, most marketplaces have actually adopted the principle to store listing prices on chain, especially if there's not a gas fee problem. So you can get that data without having to hit a third-party API.
It's certainly what we did at Ultra.
Yeah, and I think that's the best way to do it, and it really kind of keeps to this open web philosophy and like makes for good building blocks. For us, when we, especially when we're operating with ecosystems, if there's data that's third-party API that you can't get because it's not stored on chain, what we do is typically there's going to be an on-chain precursor. So let's say that there is an approval on this NFT. I can see that on-chain. We index that first, and then we kick off a parallel process to query the third-party API. So we're really focused on like on-chain data. That's always the building blocks. And then we'll query third-party APIs if you have to fill that data in and kind of keep it updated. And then, so that's kind of what we do for listing data. For off-chain data, and you'll actually see this if you start playing with the NFT API, is say like in the first milliseconds that an NFT gets minted. What we do is we'll have that NFT. So we get all the on-chain data. So we have token ID, smart contract it came from, kind of all relevant information, like block it was created, etc. It exists until it gets scraped as just what we call, internally we call like a skeleton NFT. So it's just the data. So we don't miss any actions. We don't miss any transactions on NFT. The NFT is stored there. And then in a separate process, I think processor, on the indexing kind of framework, kind of separate engine, we then go to IPFS, scrape all the relevant metadata, and keep track of it. And then we index. A lot of blockchains now will have standards around how to let all the indexers know if an NFT metadata has been updated. So there'll either be like an event that's emitted that NFT metadata has been updated, and then we kick off a new scraping event to get the relevant info. So that's kind of how we handle the on-chain, off-chain discrepancies.
Amazing. Joshua, I wanted to thank you for your time and your expertise.
Appreciate it. Thank you for having me on.